Welcome to Get Your FRQ On. This question is from 2010, Form B. It's question 4, and it is not calculator active. In the question stem, we've got a squirrel starting at a building A at time t equals 0, traveling along a straight horizontal wire connected to a second building, building B. Over the interval from 0 to 18, no units provided, the squirrel's velocity is modeled by a piecewise linear function defined with a graph, which is provided in the actual exam. In part A of this question, we are asked, does the squirrel change direction on the interval from 0 to 18, and to provide a reason for our answer. We know that the squirrel will change direction whenever its velocity changes sign. That could be from positive to negative or negative to positive. It doesn't matter. It just needs to change sign. So referring to the graph provided, we can tell that the velocity will change sign at t equals 9 and t equals 15. In part B of this question, we are asked about the interval from 0 to 18 inclusive, and we need to determine when the squirrel is farthest from building A and how far is it. The squirrel will be the furthest from building A at t equals 9 or t equals 15, or at one of the endpoints of the interval, which would be t equals 0 or t equals 18. Since v of 0 is 0, and the squirrel starts at building A, the position of the squirrel at t equals 0 would just be 0, since it's 0 away from building A. And we can find the position of the squirrel at the other values by evaluating definite integrals. The integral from 0 to 9 of v of t dt using the graph is 140. The integral from 0 to 15 of v of t dt is 90. And the integral from 0 to 18 of v of t dt is 115. So the squirrel is furthest from the building A at t equals 9 when it is 140 units away. In part C of this question, we are asked to find the total distance that the squirrel travels during the closed interval from 0 to 18. The total distance that the squirrel travels over the closed interval from 0 to 18 is given by the integral expression, the integral from 0 to 18 of the absolute value of v of t dt. Using the graph provided and getting the values that we would need, the integral from 0 to 18 of the absolute value of v of t dt is going to be 140 plus 50 plus 25, which turns out to be 215. In part D of this question, we are asked to find expressions for the acceleration of the squirrel, the velocity of the squirrel, and the distance, x of t, from building A over the open interval from 7 to 10. From time t equals 7 to time t equals 10, the velocity follows the linear function given by y minus 20 equals negative 10 times x minus 7. This implies that for the open interval between 7 and 10, a of t is negative 10, since that's just the slope of the velocity function, which happens to be linear, and v of t is negative 10x plus 90. X of t would be given by x of 7 plus the integral from 7 to t of negative 10k plus 90 dk, which is 120 plus negative 5k squared plus 90k evaluated between k equals 7 and k equals t, which turns out to be negative 5t squared plus 90t minus 265. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.